Continuing with section 5.3, part 4 is on redundancy and reliability. Here's an example. Suppose a company has two people working independently, that's an important word, to perform the same inspection of 2x4 timbers. Their job is to identify low-quality timbers. Given that the probability that an inspector fails to identify a low-quality timber is 0.20, find the probabilities. So, I think what's missing is what those probabilities were, but let's say what these are. First, we want to note that this was independent because of this word. They tell us that. And they've told us that the probability that the inspector fails is 0.20. So what we want to find out first is the probability that both inspectors fail. So in other words, they're both looking at every piece of timber, right, independently, and determining whether or not it's a good piece. And this would be the probability that a bad piece got past both inspectors. The first person missed the defects and the second one missed the defects. So they both failed. And of course, we know what that's going to be because that would, let's write it another way, fail and fail. The first person fails and the second inspector fails. And means multiply. Probability the first one fails is 0.20. This is independent, so the probability of the second person is not affected by the occurrence, the first occurrence. So multiplied by 0.20. Or we could write this as 0.20 squared, which is 0.04, which is 4% if you change that to a percent. So there's a 4%, even though there's a 20% chance that one inspector, 0.20 would be 20%, 20% chance that one person, if they only had one inspector, 20% of the time they would miss the defects and you would have defective timber going through your process. However, if you add a second person to look at it with the same probability of failure, look at the difference. Now it's only a 4% chance that a bad piece of timber gets through. So let's see this note. If the company wants the probability of overall failure to be below 1%, how many inspectors should be hired? So this is not below 1%, 4%. So what I'm going to do, since this is down here kind of low, I'm going to come up here to calculate this, but let's just see what happens with 3. This was 2, so let's put the probability that 3 fail. Say they hire another one, so that'd be the probability of fail and fail and fail. So say they want to be able to say that only 1% of their lumber is bad, has defects, that is high quality lumber. So how many inspectors need to look at this lumber? We know that if 2 do it, they can't say it's less than 1%. But let's add a third person. So in other words, 0.20, and of course we're going to raise that to the third power. We don't need to write it 3 times. And what do we get? 0.008. Okay, that did it. If it had not been below 1%, I would just add a fourth one and see what that number was. But that did it. So if they hire 3, they should hire 3 inspectors because this is what we found. 0.008 is less than 0.01. Sorry, 0.01. 1% is 0.01. Move the decimal 2 places, so that should be 0.01. 0.008 is less than 0.01. Okay, let's look here now at part B on some exercises about independent events. Determine whether events A or B are independent or dependent and justify your answer. All right, so remember, is the probability of the second one affected by the fact that the first one happened? So if you rob a bank, Does that affect the probability of you going to jail? If so, these events are dependent. If not, they're independent. What do you think? Well, you're right. They are dependent. Because if you rob a bank, you increase your chances of going to jail. That will affect this probability. Okay. And part B, the event A, you win the lottery. Does that affect the probability of you having red hair? Well, that even sounds silly. And of course, no, those are independent. Winning the lottery will not affect the probability that a person has red hair. Part C, not paying your power bill on time. If that happens, will that affect the probability that your power gets cut off? Of course it would. So we would say these are dependent. You will affect the probability of your power getting cut off if you don't pay your bill on time. Okay, we'll continue in the next video.